Dear students of Vocational Training Diploma on Electrical and Hybrid Vehicles, I am Engineer Mohammed Masad from the University of Jordan, member of EcoCar Committee, under the Erasmus Plus project, which is coordinated by the University of Jordan. My students, we are still in cluster number 5, which is about basic of electricity and electronics. Hello and welcome again in the fourth lecture of topic number 3 about basic electrical theory. The duration of this fourth lecture will be about nearly 1 hour and will cover the following two chapters. First chapter, concepts and theories of Ohm's law. The second chapter about the relation between voltage, current, resistance, and power. Concepts and theories of Ohm's law. This chapter will give an introduction about the concepts and theory of Ohm's law, which is considered to be one of the most basic and important laws of electric circuits. It gives a brief about the relations between voltage, current, resistance, and power with formulas. This chapter contains two subjects: introduction to Ohm's law formulas, concept of Ohm's law. The law states that the current through a conductor is directly proportional to the voltage across the two ends of conductor. This shows the concept of voltage, current, and resistance. This is the voltage, this is the current, this is the resistance, and this is the current. So this shows more voltage, more flow, more strength for this person to go through this conductor or go this pipe. Okay, and if this is more strength for this person, means more resistance, so it prevents to flow or to go for this person go through this conductor or this pipe. So this shows the concept of Ohm's law. Now, definition of Ohm's law. Ohm's law describes the flow of electrical current. So we have here current through a resistance when a voltage is applied at each end of a resistance. So this is voltage. So Ohm's law, okay, describes the relation between current, resistance, and voltage. See here, this is a resistance, okay, this is voltage across this resistance, and here is a flow of current through this resistance or this resistor and come back to the negative side of the power supply. So this relation, as we said before, current, voltage, okay, this relation was discovered by George Simon Ohm. This person who discovered the relation between current and voltage, and also the flow of the current through a resistance, okay, when there is a voltage applied at the end of resistance, here and here. Ohm's law formula. Ohm's law describes the relation between the three characteristics of the electrical current. This is circuit, closed circuit. Okay, we have here a voltage, we have here a current, we have here a resistance. So for the formula for Ohm's law is the voltage, which is equal to the current multiplied by the resistance. This is the formula for Ohm's law. Also, from this formula, we can have also the formula for the current, how to calculate the current, which is equal to the voltage divided by the resistance. So also this is Ohm's law, like this one also. The flow of current I is measured in amperes. So the current is measured in amperes, and the resistance to flow in the conductor, the resistance to flow in the conductor are the is in ohms. Okay, the unit of the resistance is ohms, and the unit for the voltage, okay, in voltage. Ohm's law triangle. The Ohm's law triangle helps to calculate voltage, current, and resistance as shown in this triangle. This is triangle. We have here show the difference equation for Ohm's law to solve different variables for the voltage, current, and resistance. And in this triangle, we see that the voltage is all the time on the top. Now, let's see some practical units for Ohm's law. Ohm's law may be stated as amperes equal voltage divided by ohm. 1 ampere equal 1 volt divided by 1 ohm. 1 volt, 1 volt here, 1 volt equal 1 ampere multiplied by 1 ohm. 1 ohm equal 1 volt divided by 1 ampere. So Ohm's law formula, okay, from these these equations, show the relation between voltage, amperes, and ohms. If you know two of them, you can calculate the other two. And also, this is also from the triangle of Ohm's law. If you know of the two of the triangle units, you can find the other one. See here, you have your voltage. If you want to know the voltage, okay. So if you can get the voltage by multiply by current by resistance. Okay, if you want to calculate current, so it's equal to the voltage divided by the resistance. If you want to know the resistance, it's equal to the voltage. Now let's see the linear shift between voltage and current when the resistance is fixed. Now in this example, uh, according to Ohm's law, uh, voltage current characteristics, voltage I characteristics are given below, corresponds to the electrical resistance 10 ohm. So we want to see this picture, which consists of the DC power supply. It is a variable from 10 to 60 volt to feed with current, and this current can be measured by using this ampere meter to measure the current, which goes from the power supply, goes through this resistor, okay, and come back to the negative part of the DC power supply. And we have here a voltmeter across this resistor and across this DC power supply to measure the voltage. So we have here a fixed resistance about 10 ohm. So what the values of currents here, okay, when the DC power supplies is variable and can give us 10 to 60 volt when this resistance is fixed, as you see in this table. So according to Ohm's law, the current here is equal the voltage divided by this resistance. So we have here increasing of voltage. Now we have different values for ampere from 1 to 2 to 4 to 6 amperes. So increasing of voltage, we have here increasing of current when the resistance is in ohm. So what is the relation between voltage and current when the resistance is fixed? This will be discussed in the next slide. So the relationship between voltage and current is linear. How? The graphical diagram according to the Ohm's law by this formula, current equal voltage to the divided by resistance. The change in current with voltage should be linear. So the relation between voltage and current is linear when resistance is fixed. When voltage is constant, I decreases as R increases. As an example, if R doubles, I is reduced by half. I increases as R decreases. See, but here I decrease, R increase. As an example, if R reduced to half, I increases by 2. This is the graphical diagram to see the relation between voltage and current, which is linear. So when the voltage is increased, current is increased from 1 to 6 ampere, and DC when the voltage increased from 10 to 60 volt. Ohm's law formulas. Formula number 1. Ohm's law formula 1 states that that resistance in the circuit can be measured using the formula number 1, R equal V divided by I, the current. And resistance is measured in ohms, as we see in this figure. We have here resistance. This is the current when there is a voltage across this resistance. So R, according to the triangle of the Ohm's law, as this one, the resistance here equal voltage divided by I. Voltage divided by I, which is the formula number 1 when the voltage and the current are known, so we can measure or calculate the resistance. Formula number 2 states that electric current is proportional to voltage and inversely proportional to resistance. The current through the circuit can be measured using this formula: I equal voltage divided by R, resistance. So this triangle shows that when the voltage is known and also the resistance, so we can calculate the current, voltage divided by resistance. Formula, formula number 3 states that increasing the applied voltage produce more current to the lamp, for example, with more intensity. We have here, so we have here I and current are known, so we can calculate the voltage. Voltage here equal I multiplied by resistance. We finish now topic number 3, chapter number 1, and we have here chapter 2 about the relation between voltage, current, and resistance, and also with the power. So Ohm's law now we can see about it. It's a series of formulas that help us in design functional electrical and electronic system to find the voltage, current, resistance, and also power, and condense them into a simple wheel which is called Ohm's law pie chart that will be shown next slides. Now we have here a relation between four items: voltage, current, resistance, and power. Contents of this chapter: production, electrical voltage, electrical current, electrical resistance, and electrical power. The water analogy for electricity. So there is a relation between flow of water with the flow of current or flow of charge. The figure below describes water pipe analogy for electricity through a circuit, which is useful to understand the relation between voltage, current, resistance, and power. In this analogy, charge is represented by the water amount. Voltage is represented by the water pressure, and current is represented by water flow. Where charges is water, voltage is the pressure, as we see in this figure. In this figure, we have here tank of water. It's like the height of the tank, height of water. It's like voltage or potential. We have here pipe, like wire and electricity. We have here also pipe, but here there is a constriction like resistor or resistance like this, and we have volume of water passing, giving point each second like current. So this flow of water, okay, it means the same of flow of current. We have here resistance. This is constriction for the flow of water, okay, and this here a battery or voltage. This is the height of the water in this tank. So we have here a relation between water analogy for electricity and the relation between flow of water with the flow of current from the battery. Ohm's law pie chart. This pie chart give us the relation between four items: current, voltage, resistance, and also the power. So this pie chart, by using the questions below, okay, this is pie chart. This blue means power, and this is the unit of power, which is watt. This is the current, unit is amperes. Voltage, the unit of it is volt, and resistance, unit of resistance is ohms. So power, current are V. So this will show us how to calculate if two items here is known or known, so we can find the other one. For example, voltage equal I by R. If R and I are known, also we can find the voltage if the power is known, and also the current. R we can calculate by the voltage and power, voltage and current, and voltage also power and also with the current. So this pie chart help us to calculate power, current, resistance, and voltage. So this is the equations: power, watt, V, volts, and I with unit of ampere. So power equal voltage by current, and watt equal volts multiplied by amperes. Also power, you see here, watt equal V square divided by the resistance, as you see here. Also power from this way, for example, equal I square multiplied by the resistance. So these questions can give us from this wheel, and also we can find the same things for voltage and for resistance and for the current. Ohm's law matrix table. This is another technique how to calculate the power, voltage, current, and resistance. Okay. These equations condense into this table for easy reference when calculating an unknown value. So this table is like this. For example, here we have known values, current and resistance, so we can find the voltage is equal I by R, and also we can find power I squared by R. If the voltage and current are known, so we can find resistance, voltage by I, and also we can find the power, V multiplied by I. If we have power and current, so we can find out or calculate the resistance, V divided by I squared. We can find the voltage. If voltage and resistance are known, so we can find the current, and also can find the power. If power and resistance are known, so we can find the current, square root of power divided by resistance, or also we can find the voltage, square root of R multiplied by the current. Also, voltage and power are known, so you can find the resistance, voltage square divided by power, and also can find the current by dividing power divided by volt. Definition of voltage. Voltage is the pressure from an electrical circuit's power source that push charged electrons or current to flow through a conducting loop, enabling them to do work such as illuminating a light. In brief, voltage equals pressure, and it's expressed mathematically using the symbol V or E and measured in volts. Relationship between voltage and current. We have here a tank with water tap, and here this is the flow of water. So the height of the tank means voltage, electricity, and current means like the flow of water, and the manual controlling of this water tap is the resistor as in the electrical circuit. So electrical potential U or V the same, can be linked to the water level in a water tank. The electrical resistance is linked to the diameter of the pipe. This is the diameter of the pipe, allows a lot or little water to escape from the tank. The analogy of electrical current I, to the amount of water flowing in 1 second. So this is give us a relation between voltage and current, okay, like the flow of water from a tank. When there is high pressure, high voltage means high current or flow high. Multiple and submetal units of voltage. Volt is indicated by different range according to the measurement as shown in the table below. We have here bigger units of voltage. We have here smaller units of voltage. We can see kilovolt equal 1000 volts. We have more value, megavolt equal 1 million volts or 10 to the power 6. More than voltage, we have here gigavolt 10 to the power of 9 to the power 10 to the power 9 volts or gigavolts. 3 million volt 1 multiplied by 10 to the power 12 volt. So this is bigger values from kilo volt to megavolt to gigavolt to trillion volts. But for smaller units of voltage, we have here millivolts 10 to the minus 3 volt, microvolt or 10 to the minus 6 volt, nanovolt 10 to the minus 9 volt, nanovolts, picovolt 10 to the minus 12 volt. So this is many values for the units of the voltage, bigger units and smaller units. Now let's take examples of how to calculate electrical voltage in circuits. This is a question. Find the voltage applied across a resistor it's equal about 1000 ohm resistor when 10 milliampere current flows through it. So we have known value of resistance and known value of current in milliampere. So this is circuit. We have here our source voltage. We have 1000 ohm. We have here current of 10 milliampere. So what is the voltage? According to Ohm's law, voltage equal current multiplied by resistance. Solution: since R equal 1000 ohm, current equal 10 milliampere. So in this case, according to Ohm's law, voltage is equal 1000 multiplied by 10 milliampere equal 10 volt. So the voltage applied across this resistance from this power supply is equal to 10 volt. Another example, if the resistance of an electric device is 50 ohm and a current of 3.2 ampere flows through the resistance, find the voltage across the resistance. So this is circuit. We have here 50 ohm. We have here a current 3.2 ampere. So what is the voltage across the resistance? Solution: by using the formula of the Ohm's law, voltage equal the current by multiplied by the resistance. So voltage 3 equal 3.2 ampere divided multiplied by 50, so it's equal 160 volt. So the voltage is 160 volt across this resistor. As a homework, you can solve these problems. First one, how much voltage applied across 100 ohms resistor when 20 microampere current flows through it? As we see in this circuit, we have here a resistor of 100 ohms. We have here a current I in this circuit. So what is the voltage across the resistor? And also what is the voltage here? And also the same as here. Also another example, find the voltage across 100 resistor 100 ohm when 2 amps flow through this resistor. What is the voltage here? Hello my students, we want to continue about the theory of electricity, the third part of the this topic about electrical current. Again, I am Engineer Muhammad Masad from the University of Jordan, member of EcoCar committee under the Erasmus project vocational training diploma on electrical and hybrid vehicles, coordinated by the University of Jordan. And this lecture maybe takes about half hour. So let's begin the definition of electrical current. The electric current is defined as the rate of electric charge flow in an electric circuit. So the current now is electric charge flow. The charge can be negatively charged electrons, or positive charge moving through an electrical conductor. Based on the flow of charge, the electric current is classified into two types. First one is called alternating current AC, and the second one is called direct current DC. Electric current is expressed mathematically, example in formulas, using the symbol I. The unit for current is in ampere or amps and is represented by A. Water analog, to compare the flow of water with the flow of charge. The current can be considered to be like water flowing through a pipe. The pressure forces the water to flow through the pipe. The amount of water flow is proportional to the pressure. So water flow proportional to the pressure, as we see here in this picture. So we have here flow of water, we have here flow of current, electrical current. This is a circuit, and here we have a water analogy of flow of water from this tank. So this is the pressure, height of the water, or the pressure, and here is the pipe, and here is the control of the water, and we have here the tank. So more water coming from highest of the pressure, or the highest of also the height of the water inside the tank. Multiple and multiple units of current. The unit of measurement for current is ampere, as we said before, and the following units with the following units: milliamps. 1 milliamps is equal to 1 divided by 1000 of an ampere, 10 to the minus 3. Microampere is equal to 1 divided by 1 million of an ampere, is or equal 10 to the minus 6. For example, find the current of an electrical circuit that has a resistance of 100 ohms and voltage supply of 10 volt. As we see here in the circuit, we have a resistance of 100 ohms with source of 10 volt DC. So what is the current flow in this circuit? So solution: volt, 10 volt, R equal 100 ohms, equals to Ohm's law, I equal V divided by R. So we divided 10 volts by 100 ohms equal zero point 0.1 milliamps, or 100 milli point sorry zero point 0.1 amps, which equal 100 milliamperes. So the known current is equal to 100 milliamps. Problems about electrical current. Number one, how much is the current across 500 ohm resistors if its voltage applied is 24 volt? Question two, find the current when applied voltage equal 48 volt across 12 ohms resistors. So you can do it as a homework in your house, your home. Problem number two, you have here a load as we see in vehicles, 12 volt, 50, 55 watt or 65 watt. So how much current does this lamp, okay, from a 12 volt power source? Now about next subject about electrical resistance. What's the definition of electrical resistance? The resistance R of a conductor is defined as the ratio of the potential difference volt V across it to the current I flowing through it. This can be expressed mathematically as R equal V divided I. The unit of measurement of resistance is the ohms, symbolized by regulator omega. Ohm. When a potential difference of 1 volt drives a current of 1 ampere, the resistance is 1 ohm. What about multiple and sub-multiple units of resistance? We have here the unit of measure for resistance, as we said before, is ohm, omega. Resistance is indicated by different range according to the measurement, and they are the following. 1 kilo ohm equal 1000 ohm, mega ohm equal 1 million ohms. Relation between resistance and section of the wire. The resistance of conducting material is found to be directly proportional to the length of the material, inversely proportional to the cross-sectional area of the material, and depends on the nature of the material. So, if we have this material, conducting material, we have a resistivity for this material. We have here like resistance. This is the length of this material, L, and we have here the cross-section area, A. So the resistance can be calculated by equal the resistivity of the material multiplied by the length of the material here, the length of the material, divided by the cross-section area of this material, or this section of this material. So R, resistance of the conductor, L, length of the conductor, A, cross-sectional area of the conductor, and the resistivity, which is constant of proportionality of the material, known as the resistivity of the material. So is this one is differ from material to another material. This takes an example. Calculate the total DC resistance of 200 meters meter roll of 2.5 millimeter square copper wire if the resistivity of copper is 1.72 multiplied by 10 to the minus 8 ohm meter. So data given, we have known values of the copper, the resistivity of copper is 1.72 by minus 10 minus 8. We have here the coil length equal L equal to 100 meters. Here. The cross-sectional area of the conductor is 2.5 millimeters square, here, which is equivalent to a cross-sectional area of 2.5 to the minus 6 meters square. Take this formula for the resistance comparing with the resistivity, length, and cross-section. So R equal the resistivity multiplied by the length of the conductor of the resistor divided by the cross-section area here. So it is equal 3.44 ohm, which is the DC resistance of 200 meter roll of copper wire. Take another example. As shown in the circuit below, supply voltage is 12 volt, and the current flowing through a known resistance is 2 amps. So, determine the unknown value of resistance. We have here resistance, we have here 12 volt, and the current is 2 amps. So, what is the unknown resistance here? This is Ohm's law, R equal V divided by I. So, R equal 12 ohms or 12 mega. So, the unknown resistance is 12 ohm. Example 3, another example. If the power source is 12 volt connected to purely resistive electrical appliance lamp. So an electrical current of 2 amps flows through it. Consider the conducting wire to be resistance free. This here a circuit with power source and conductor and a light, 12 volt. We have a lamp, for example. So calculate the resistance offered by the electrical appliance. So what is the resistance of this lamp? So solution R equal voltage divided by I, R equal 12 volt, and the current is equal to amps. So R is equal 6 ohm. Let's take another questions here to do it as homework. Your home. What is the resistance of 50 ohm 12 volt halogen lamp? Find the resistance when 24 voltage applied across resistors when 1 amp current flows through it. Now we are in the fifth part of the topic number 3 about the relation between voltage, current, resistance, and power. We know about the meaning of the or definition of electric power. Electrical power P in a circuit is the rate at which energy is absorbed or produced. So we have here absorbed or produced energy in the circuit. A source of energy such as voltage will produce or deliver power while the connected load absorbs it. Light bulbs and heaters, for example, absorb electrical power and convert it into either heat or light or both. The higher their value of power or rating in watts, the more electrical power they are likely to consume. Calculating electrical power using Ohm's law. So using Ohm's law also to calculate the electrical power. The electrical power can be calculated by using Ohm's law and by substituting the values of voltage, current, and resistance. Power is the amount of current times the voltage level at a given point measured in watt. Power equal volts multiplied by amps, or volt equal V multiplied by I, current. Units of power. The unit of the unit of measure for power is watt. Power is indicated by a difference range according to the measurement, and they are kilowatt equal 1000 watt, megawatt 1 million watt, kilowatt hours, kilowatt multiplied by time in hours. This is the power. Use this unit in our homes to calculate the consuming power from different equipment in our home. Sub-multiple units of power, they are milliwatt or 1,000th of a watt, microwatt 1 millionth of a watt. So this is bigger values of watt, and here is smaller values of watt. Watt's law, power triangle. The power triangle can be employed to determine the value of electric power, voltage, and current when the values of the other two parameters are given to us. So, the power triangle is to calculate the value of electric power and also voltage and also current when these two values parameters are given to us. We can find the answer. In the power triangle, the power P is on the top and current I and voltage V are at the bottom. When the values of current and voltage are given, the formula for finding power is P equal V multiplied by I, as we see in this triangle. So the power here in the triangle, the top, and I and V at the bottom of the triangle. So if two of parameters are given for us, this or this or this, two of them are given to us, we can find the third one. So here, P, the top, equal I multiplied by V. If we want to calculate or determine the current, so this equal the power divided by the voltage. If we want to calculate or determine the voltage, so it is equal the power divided by the current. Power dissipation in resistance. When current flows in a resistance, heat produces current, and electrical energy, when is converted into some or other form of energy, like heat, this which is known as electric power. The amount of power dissipated in resistance may be calculated by using one of the following formula, depending on which factors are known. You can see here how to calculate the power by using factors like V, voltage, or I, or resistance. So there is a relation between power and voltage, current, and resistance according to this equation, okay, which is coming from the triangle of power. Let's take an example. How much power is dissipated by an 4 ohm load if the current in the load is 3 amps? So this circuit, we have here a source of 12 volt with resistance 4 ohm, and current is 3 amps. So what is the power dissipated in this load or in this resistance? As we know from the triangle of the power, power equal voltage multiplied by current. So voltage is 12 and current is 3 amps. So the power is about 36 watt. Also, we can calculate the power by using this resistance according to this formula. V multiplied by V divided by R, which is equal V squared by R, which is equal 12 by 2 multiplied by 12 divided by 4 is equal 36. Also we can calculate the power of when we have the current and the resistance only. So we know the current I squared multiplied by R, 3 multiplied by 3 by 4 is equal 36 watt. Let's take another example about electrical power. If a current is 1 amps, resistance equal 1000 ohm, what is the power dissipated in a resistance R as you see in this circuit? In this circuit, we have here resistance about 1000 ohms, current about 1 amps. Solution, as we know that power equal voltage multiplied by current according to triangle of the power. So we know that the current is 1 amps and R is equal 1000. So this is a formula for the power, I square R. So 1 multiplied by 1 multiplied by 1000. So the power is about 1000 watt, which is equal 1 kilowatt, which is the power dissipated in this resistance when we applied a voltage across this resistance and deliver about 1 amps in this circuit. Let's take another example. What is the resistance of radiant heater that dissipates 1000 of power when its current is 5 amps? Like this heater have a radiant heater inside it about 1000 watt. So the solution here, power equal V multiplied by R, and this radiant heater, we know the power is 1000, so 1000 equal voltage is about 200 from the mains, and the voltage also multiplied by V, 200 divided by R. R equal 200 multiplied by 200 divided by 1000, so 40,000 divided by 1000. So the resistance of this radiant heater is about 4 ohm. About electrical power, some questions are here for you to solve it in your home. Question 1. How much power is dissipated by an 8 ohm load if the current in the load is 200 milliamps? Second problem. How much power is the output voltage of power supply if it supplies 10 watt of power while delivering a current of 10 amps? Another problem to solve it also in your home. What is the dissipated power by a resistor R in this circuit if we have 1 amps from the power supply flow through the resistor R of 100? So what is the power? If the current is decreased to 20 milliamps and the resistance increase to 1 kilowatt. So what is the power? If the voltage is known with 5 volt and resistance is 150 ohm, so what is the power? If the voltage is increased to 20 volt and R increased also to 1 kilo ohm, what is the power? And what is the relation for the values of power comparing to the increasing or decreasing of current and also of voltage, also with increasing of resistance here. Now we finished this topic number 3, and this is some references for you to visit these links to get many information about these chapters belongs to topic number 2 about basic of electricity theory. Thank you again for your attention. Thank you. Any questions, my students?